the next question to you will simply say now, calculate the volume of hydrogen gas produced at STP, guys. If that question there, guys, you do it correct, it will be easy for you to get that one right. Yeah, but yeah, if this one you do it correct, it will be easy for you guys to get this one right, because now this is what will happen there. We know the moles of hydrogen gas, and we know they said STP. I know the moles now. I know the moles. Now I'm solving for what? For a volume there. Meaning this is what will happen there. And let me indicate this one is what? It's 5.1.1. Now I'm on 5.1.2. Meaning now I'll use this equation whereby this, guys, I already solved it here, which is that it's 0.0625. This it's constant divided by that. So here I can do cross multiply. This will come here, that will multiply there. So this is what will happen. V will multiply with 1. Anything, guys, when you multiply with 1, you get the same thing, which is V there. Then these will multiply each other, 20,4. Meaning our V, guys, is a hydrogen gas, a volume of a gas, guys, at STP. Volume of a hydrogen gas, guys, there it will be this one multiplied by 22,5. So meaning this one is a volume, guys, of a gas there, of a hydrogen gas there. Hydrogen gas, which is decimeter cube. Do you see? Yeah. So now let's dive deep, guys, to the next question there. Alright, guys, here these marks are so free, guys. This thing is already 10 mark. What about this one? Calculate the mass in grams of produced there. Produced. So now we want to get, guys, the mass of this thing there in grams. In order for you guys to get a mass of this thing there, a mass of that thing is the one which is what? I don't know the name of this thing, but they need a mass of that there. A mass of MgCl2 there. We want to solve the mass of this thing there. A key thing, guys, there, what you should understand is that we should know the moles of this Cl2. If we can know the moles of this, which is if here we can know the moles of this, we can get that, because this one will get it from the periodic table. Do you see? But how can we get the moles of this thing? Remember what I told you about what? A molar ratio. What is a molar ratio? A molar ratio, it is whereby we'll compare this thing with what we are given there. So I can compare this with that one there. Because there I know the moles of this, because I already calculated where? Here. So meaning that those two things, guys, I can compare them using a molar ratio. So this is how you compare them, which is this and this, Cl2. And we'll take the coefficient of this thing there, which is invisible 1, coefficient of that there, which is also invisible 1. Yeah, it's also the invisible 1. But because, guys, I know the moles of this thing there, because I already calculated there, which is that this thing will be 0.0625. Then for that one there will be what is the one that I want to solve the moles there. So it simply says that I will do cross multiply there, this multiply there. Meaning this multiply with that one there, which is HCl2. And this there it's 0.065 multiply by 1. So this is what I will get there, which is mole there. Which is that thing, it's a mole, H, or it's M, guys, not H. It's MgCl2. Do you see? Yeah. And another key thing, guys, that I would like to advise you, if the ratios, guys, are equal, it means that if the ratio are equal, it's 1-to-1 ratios, it means that they will also have equal moles there. If the ratio are equal, it means that also the moles will be equal there. Just like here, the ratio they are equal, also that the moles they were equal there. Do you see this thing? Yeah. So now guys, I know the moles of this thing. Yeah. So once I know the moles of this, it means I can apply that equation now of saying here it's m over that. Then I substitute there to solve my mass there. Oh, before guys I substitute, here's another key thing there that I should get. I should find a molar mass of what? Of MgCl2 there. I shall find the molar mass of this thing there. So there, for me to get the molar mass of this, I will use my periodic table there, which is whereby Mg, where is Mg? Mg there, it's 24 plus, here we got 2 chloride there, which is chloride. Here is a chlorine, it's a chlorine guys, which is this thing 35,5. Then I can punch this thing on my calculator. 24 plus 2, which is 35,5. Oh, here it's 24. Yeah. So this is what I get there, which is 95 grams per mole. I got the grams per mole. Then now I can substitute now. This, I have it because I already solved it. 0,0625, which is 20, that which is m there. Oh, it's small m guys, don't do the big M, it's small m there. So now what I can do cross multiply, this multiply here, this multiply there. This will become m, which is 0,06 there, multiply by 95. So there I will get my answer 0, this multiply by that, which is, this is what I get there. So because guys I will be writing my final answer, I will round this number into 2 decimal places there, which is 4 grams, meaning now the mass of this magnesium chloride, it will be 5,94 grams. Do you see? Yeah. So guys, on your final answer, you round your answer into 2 decimal places. But during your calculations, guys, you don't round off a number. No, you don't round off here. If you are still calculating, no need for you to round off. You only round off on the final answer. Do you understand? Yeah, on the final answer, that's where you round this thing into 2 decimal places there. Imagine, guys, you come across a question like this. Calculate the number of chlorine atoms there. They say chlorine atoms present in this thing there. They need the chlorine atom there which are present here. A key thing, guys, now that you should understand about this question, what are they asking you? Number of chlorine atoms, meaning they ask you about the number of particles there of chlorine there. But now which are present where here on this compound there. They are present in that compound. So what you should understand, from that compound, guys, we already solved a mass, a mole of this thing there. Oh yeah, we already solved the mole of this thing. Where is it? Is that one, which is that thing is 0,0625 mole. So we already solved the mole of this thing there. Those moles, guys, they also represent the moles of chlorine there, which is 0,025 there, mole. So there we got 2 chlorine. It means they will get how many atoms of those 2 chlorine which are in this compound. How many atoms of chlorine there which are in this compound. Do you understand? Yeah. So all of that thing there, is the same as that one. Do you see? Yeah, it's just that this question, guys, they won't come direct. The number of chlorine atom present in they didn't even tell you in what, in how many moles all. They didn't tell you about moles. But you as a learner, you should be smart there, because you know the moles of this thing there are these ones. And those moles, they also include a chlorine there, by the way. Meaning now you should get the what? The number of atoms of chlorine there in this thing. So the first thing that you should know, guys, is the equation to use. So this is the equation that I will use, which is n is equal to n over n Na there. Remember, guys, according to your equations there, this is the equation that you can use. You are calculating a number of atoms or a number of what? A number of particles there. You got this thing, you know that one is constant, so now you can just substitute there. This thing there, you have it 0,025, which is here, it's equal to 6,0 multiply the 23 divided by n. So now what you can do there, you can do your cross multiply, this multiply that, this multiply that. So here it will be n 0,0, yeah, multiply by 6, 20, 25. Meaning that now this, you should press it on a calculator, which is 0, that 26 multiplied by this, which is the 25. Yeah. So this is what you get there, which is that it's 3,7625 that particles there. But now, guys, when you conclude them, you can just write this thing in a complete sentence.